So students, this is basically I'm giving you for in-class activity. We have designed for out-of-class activity previously. Now what we want is what we will do in the in-class activity. As you have studied about the counter, this you have already studied about the counter. What is counter, what is asynchronous counter, what is ripple counter, how to make the timing diagrams for that. Now you should be prepared that we will discuss the problems in the in-class activity. So here what I am telling you is what we will do here. Basically we are designing a modern asynchronous counter, and it is how we will design a modern asynchronous counter. Now you can see down counter and up down counter, divide by n counter, and all these things. What is mod n counter? For example, in mod n counter, what we have to do, detect a terminal count of n in modulo n count sequentially to asynchronously clear the count to 0 or asynchronous load in value 0. These leads to counts which are present for only a very short time and can fail to work for some time condition. Detecting a terminal count of n-1 in a modulo n count sequence to clear the count synchronously to 0. Detect a terminal count of n-1 in a modulo n counter sequence to synchronously make the count up to the 0. Now next is, for example, detecting a 7 and asynchronous clear. Asynchronous 4-bit binary counter with an asynchronous clear is required, and use the clear feature to detect the count 7. So in class what we will do, we will design a mod 6 counter and we will discuss the assignment problems with each other, which will make the count very easily.